Welcome to part 4 of the Semester 1 review packet. This video will cover questions 16 through 20. So first up with number 16, we're asked to find two compositions of functions. Sometimes called FOG is f of g of x, and the other one is g of f of x. So for the composition, we're going to take the inside function and plug it into the outside function. So for the first one, we're going to take the x minus 1 and plug it into function f. Well, f of x is x squared, so f of x minus 1 would simply be the quantity x minus 1 squared, or x squared minus 2x plus 1. For g of f of x, we'll take the f function and use it as our input in function g. So we take the x squared, we plug it in here, and we get x squared minus 1. Okay, number 17, we're supposed to define the domain of f, g, and f of g of x. So for f, we see a radical. And we know what's inside the radical must not be negative. So it's simply x is greater than or equal to 0. In interval notation, from 0 to infinity. Then for g of x, there's nothing here that restricts the domain, so it's all reals. And the last part, what is the domain of f of g of x? So I don't see any restrictions for g, so I'm going to go ahead and plug that into function f, and what we end up getting is radical x squared plus 1. So when is x squared plus 1 greater than or equal to 0? And you may know the answer already. X squared will always be greater than a negative number. So the domain is all reals. Number 18, we have f of x. We want to find the inverse informally, and then verify by using the definitions of functions and inverses. Well, you may not know how to find this informally, so it's okay to go ahead and go through the longer process. Here's the original function. I just plugged in y instead of f of x. So we swap the x and y values, and we solve for y. So we'll multiply both sides by 4, giving us 4x equals y minus 1. And then add 1 to both sides, y equals 4x plus 1. So f inverse of x is equal to 4x plus 1. Now the verification part for the first one, we'll go ahead and plug this into function f. So we get 4x plus 1 minus 1 all divided by 4. Combining like terms, we get 4x over 4, and we know that 4x divided by 4 is x. Now going the other way, we're going to plug our f function into the inverse. So f inverse of x minus 1 divided by 4. So 4 times x minus 1 divided by 4 plus 1. Well, these 4's cancel out, giving us x minus 1 plus 1, or simply x. Okay, for number 19, we're trying to find the composition of G inverse and F inverse. So that requires us to find the inverse functions first. So for f of x, I'll go ahead and swap the x and y values. And then solve for y. And you probably could have done this in your head, because the inverse of adding 4 would be subtracting 4. So f inverse of x is equal to x minus 4. We'll do something similar for g of x. We'll swap the x and y values. And then we'll solve for y. We'll add 5 to both sides. And then divide both sides by 2. Y equals x plus 5 over 2. So G inverse is x plus 5 over 2. So then, to find the composition, which is G inverse of F inverse, we'll take our F inverse function and we'll plug it into G inverse. So, combining like terms, we get x plus 1 over 2. And that's our answer. Okay, number 20, given the quadratic function, identify the vertex and the intercepts. Now, it's true that these can be found on the calculator, at least the vertex and the x-intercept. But I want to show you how to do it without a graphing calculator. For any quadratic, the x-coordinate of the vertex is simply negative b over 2a. So in this one, a is 1, b is 2, and c is 1. So I get negative 2 over 2 times 1, or negative 2. I'm sorry. Silly me, negative 1. But that isn't the whole vertex. That is just the x-coordinate. So I find f of negative 1, negative 1 squared, plus 2 times negative 1, plus 1, and I get 0. So the vertex is at negative 1, 0. Now, to find the x-intercepts, we set the function equal to 0. So this one we can factor. And so we get a double root of negative 1. So the x-intercept occurs at negative 1, 0. Then for the y-intercept, we plug in 0 in for x. So we find f of 0. So 0 squared plus 2 times 0 plus 1. F of 0 is equal to 1. So the y-intercept is at 0, 1. That concludes part 4. We'll go ahead and do problems 21 through 25 in part 5.